have an array like this, right, that contains four elements, and if you notice, it has a duplicate in it, right? Whenever you come across a problem, you should always first think of a brute force solution, right? What's the easiest way you can solve this problem? And the answer here lies in comparison, right? You can compare elements to each other, right? That's the basic truth. You can compare one to all of these three elements, and if it's equal to another number, that means you found a duplicate. So in this case, we start from this position, right? We compare 1 to 2, oh, it's not equal, so we move on. We compare it to 3, it's not equal, we move on. We compare it to 1, oh, we found a duplicate, right? And if we found a duplicate, the answer should be true, right? So the brute force approach lies in comparison, right? Let's look at another example where we do not have a duplicate, right? Let's say we have an array like this. We have a pointer here, right? And we compare 1 to each and every element in the array, right? So no duplicates found. We move our pointer here. We compare it to the rest of the elements, 3 and 4. No duplicates found. Keep a pointer here. We compare it to 4. No duplicates found. So here the answer is false, right? So the brute force approach, the comparison approach, you will need two for loops, right? You will need two for loops, and basically you will compare elements to each other, and as long as you elements are not equal, you're good. The loop keeps going, and at the end, if you do not find any duplicates, you return false, right? Now obviously brute force approach is not that great, right? The interviewers are mostly curious if you can come up with like an optimal solution, because it's all about saving time and memory, right? And here, the answer to optimal solution lies in a data structure, right? And if you don't know about it, it's fine. It's something that you can learn, right? But here you can make use of a data structure. Let's change colors here, right? Called set, right? Set by definition cannot have duplicates, right? There's no chance a set will ever have a duplicate element in it. Every element in a set has to be unique, right? So let's think about this. You have the input array here. Let's say it's 1, 2, 3, 4. And let's say this is your set, right? What we can do is we can go over each element one at a time and start adding these elements to this set, right? So we start from 1, right? 1 is not present in the set, so we add it to the set. Look at 2, not present, we add it to the set. Look at 3, not present, we add it to the set. 4, not present, we add it to the set, right? No duplicates found. The answer is false. Correct. Now let's look at a example where we have a duplicate, right? So let's say we have 1, 2. Let's look at our first 1, 2, 3, 1, right? And let's say we have a set here, right? So first element we add, we have a 1, we add it to the set. We have a 2, we add it to the set. We have a 3, it's not present, we add it to the set. We get a 1. Oh, 1 is already present in a set. So the set here will reject this one, right? And you should get some kind of a output from your function call when you're trying to insert elements in a set, right? In case of C++, you get a pair back, right? You get a pair of an iterator and a boolean. The boolean indicates whether the element was successfully inserted or not. So in this case, you should get back a false, right? And that's your reason to return a false, sorry, a true from your function, right? That you found a duplicate.
Alright team, enough talking. Let's write some code. Right, so we said the brute force solution is going to require two for loops, right? So let's start by writing a brute force solution, and let's have two for loops here. So let's get them structured, right? we said we are going to start by looking at the first element. So our outer for loop will start from an index of 0 as long as it's less than nums dot size. We should keep looking and we can increment the pointer, right? Our inner loop will start looking at the elements that's one past I, right? So in the first iteration, it will start looking from the second element in the array, right? So let's do j equals to I plus 1, j less than nums dot size plus plus j, right? And so once when we are comparing the two elements, if they are equal, that means the array has duplicates, right? And in that case, the requirement says we want to return true, right? So this case means we found a duplicate and we want an early return. So the function will end here and boom, right? The answer is true. Now, in case there are no duplicates, we will never hit the if clause. The for loops will finish and we should return a false, right? We did not find any duplicates. So if I run this code, hopefully, yes, accepted, all three test cases pass, but let's try submitting this, right? And let's see what happens. Ooh, time limit exceeded, right? For case 70, time limit was exceeded. Now, this doesn't mean that the solution was wrong. All that it means is for this particular input, the algorithm was slow, right? And as the description says, we can have the array can have at max 10 raised to 5 elements. So this brute force approach is not going to work, right? Let's try writing a optimal solution, right? Which we said is going to make use of sets, right? In C++, I think unordered sets are slightly better. So let's make use of unordered set of type in. Let's call it nums underscore set. Let's go over the elements in our input array one at a time, and we can use const auto uh, ref. Let's call it n nums, right? And let's insert elements from this array into the set one at a time, right? So nums set, this unordered set class provides like an insert function, right? And we can insert our elements in here. Now the insert function returns a pair, right? And if you don't know what a pair is, it's fine. Pair, think of it as a container of two elements, right? The first element that insert will return that's in the pair will be an iterator, and the second will be a boolean indicating whether this element was inserted or not, right? So if we simply surround this with an if and access the second element, which is a boolean, right? And if the element was not inserted, this boolean will be equal to false, right? If the element was not inserted, what does that mean? That means there's an element in the set that is equal to the element that we're trying to insert, right? That means a duplicate is present. So in this case, we return a true, right? And if all of this is fine, at the end we did not find a duplicate, we return a false, right? Let's run this solution, right? Accepted, all three test cases are good. Let's try submitting this, and there you go. 33 ms beats 51%, right? So there you go guys, contains duplicate.